In A-level maths, it's a really good idea not to always find the exact answer to a problem by doing things like the square root of 3 and getting a decimal answer. It's much better and much more accurate to leave it in a form known as surds. And here is a quick look at some basic introductions to do with surds. You may have covered some of these at GCSE in maths. The rules for surds are the square root of a times b can be written as root a times root b. So let's have a look at an example of this. So we're looking at the square root of 75. Now the square root of 75 doesn't give you a nice rounded answer, but there is a square number that does go into 75. And if you know your square numbers, well, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and 25 happens to go into 75 3 times. So we can rewrite 75 as the square root of 25 times by 3, which is the same as saying square root of 25 times by the square root of 3. And the square root of 25 is 5, so it's 5 root 3. And that is your answer in surd form. Another surd rule, number 2, is the root of a divided by b is the same as saying root a divided by root b. So, here's an example. We're going to do root 27 divided by root 3. And 27 divided by 3 is 9. So we're actually going to look at the square root of 9, which is 3. When we're looking at surds, we only look at the positive answer. We don't look at the negative answer. Right. We can also add surds together. So a root m add b root m is equal to a add b root m. Now, please notice, like with fractions, you've almost got to have a common denominator. Well, here you've got to have a common square root, so it's both m's in both parts. So we're asked to do root 3 add root 12. Now what we can do is we can convert root 12 into a form including root 3. So root 12 can be written as 4 times 3, because 4 is a square number, which is root 4 times root 3, which is the same as saying 2 root 3. So our question now becomes, let's just change colour, our question now becomes root 3 add 2 root 3, which is 3 root 3, because there's a 1 in front of this. Right, rationalising the denominator is a really important skill, and there's actually two we're going to look at, two examples. We're going to look at one at number 4 and one at number 5. Now, rationalising denominator is basically getting rid of this root 5 on the bottom, because we don't like it, because it doesn't look very good. So we like to convert these so that all roots are on the top of a question. So what we're going to do here is we're going to multiply to get rid of that. We're going to multiply both the top and the bottom by root 5, and you'll see what happens. Okay, so we're going to do 10 root 5 times root 5 over root 5. Now 10 times root 5 is just 10 root 5, but there's something really clever that happens at the bottom here. Root 5 times root 5 actually gives you the answer 5, which makes sense. You think about it. If you think about a nice easy example, so let's do something like root 16 times root 16. Well, you know that root 16 is equal to 4, and 4 times 4 is equal to 16, which is the same as saying root 16 times root 16, and if you notice that the 16 is what we get. So let's just tidy up what we were doing here. So 10 over 5, well, that's 2, so the answer is 2 root 5. Right, expanding double brackets involving surds. Well, that's exactly the same as any double expanding questions we've ever done before. you expand it by doing root 5 times root 5. And if you remember back to my explanation a minute ago, root 5 times root 5 is just 5. Then we do root 5 times minus 5, which gives us minus 5 root 5. Then we do 3 times root 5, which is 3 root 5, so plus 3 root 5. And finally, we do 3 times minus 5, which is minus 15. So that is the expanded form. Now we can collect together a couple of bits. We can collect together the values. So the values, so 5 minus 15 is minus 10, and minus 5 root 5 plus 3 root 5 is minus 2 root 5. And that's the expanded form of what we started with. Now for question number 6, we're asked to rationalise 2 over 3 plus the square root of 2. Now I'm just going to write this a bit further down so we've got a bit of space. So we're looking at 2 root 3 plus root 2. Now this is a difficult skill, but all we've got to do is we've somehow got to get rid of this plus root 2 on the bottom. Now the only way to do that, because if we times that now by the same thing, let's just try that. If we now times that by 3 plus root 2 on both the top and bottom, like we did before when we rationalised, let's just see what happens. Well, the top bit becomes 2 in bracket 3 plus root 2. That's fine, but this is where the problem comes on the bottom. We're going to do 3 times 3, which is 9. 3 times root 2, which is 3 root 2. Root 2 times 3, which is 3 root 2. And root 2 times 2, which is 2. Now, if we collected all that together, we're still no closer to actually solving the problem, because we're still going to have root 2 on the bottom, because we'll have 11 plus 6 root 2. So we're no closer to solving the problem. So instead of timesing by 3 plus root 2, we actually times by negative root 2 instead. So we times by the opposite sign to here. So instead of 3 plus root 2, we're going to times the top and bottom by 3 minus root 2. So let's just start this question again at the bottom. So the question we're going to start with, so let's just put a big line through that to say we're definitely not using that, that's wrong. So instead we're going to do 2 over 3 plus root 2, and we're going to multiply it by 3 minus 3 root 2 and 3 minus root 2. And if we do that, on top we now have 2, 3 minus root 2, and on the bottom we now have 3 times 3, which is 9, 3 times minus square root 2, which is minus 3 root 2, root 2 times 3, which is 3 root 2, and root 2 times minus root 2, which is minus 2. Now you should notice here that something really nice has happened, that actually the top bit stays the same, but it should be a 2, not a 3. Let's change that. On the bottom you should notice that we've got a plus 3 root 2 and a minus 3 root 2, which means they cancel out. So we're only left with 9 take away 2, which is 7. Now we're just going to tidy this up by expanding the top part. So we're going to have 6 minus 2 root 2, and that's all over 7. So remember, when you're rationalising a denominator and you've got something along the lines of 3 plus root 2, you're going to times both the top and the bottom by 3 minus root 2 to eliminate the root from on the bottom of the fraction. So surds, as I said, are a really important skill in A-level maths, and you can be asked, it is perfectly acceptable to leave your answer in terms of surds throughout your A-level maths course, because it is a more accurate answer.